Okay, hi guys. Welcome. We'll be discussing variation of parameters today. So basically, we discussed for second order linear differential equations in the case of, in the homogeneous case, in the non-homogeneous case for like the more regular types, which is like trig, like the regular trig, exponential, and linear equations. But what about if they like look really weird? So let's explore that. Uh, this idea is a kind of mystery. Let's explore. So y double dash plus y is equals to tan x. And it's hard to solve this without variation of parameters. I don't think it's possible. So in this case, g of x, which is this, is not equal to 0. It's not the homogeneous case. It is a non-homogeneous case, but it's like you cannot use method of undetermined coefficients because this is clearly not sine or cos, and nor is it linear, nor is it exponential. So here's how we solve it. Okay, so first what you're gonna do is find the like find the common like homogeneous case, which is like y double dash plus y is equals to 0. So that would be r square plus 1 is equals to 0. So it means that r is plus minus I. Okay, so this also means that the common solution or the homogeneous solution is, so since there is nothing here, we won't put anything. um it would be it would be cos, sorry, it would be sine of x plus cos of x. Right, let's just make sure that I made no mistakes. I'm so sorry. Yes, I'm correct. So this is how we would write it. All right, now moving on, consider, imagine we replace the constants in this case, which was c1 and c2, with uh instead of constants we consider them to be functions. Like c1 becomes u1, which is a function, and c2 becomes u2. So we get the case where u1 sine x plus u2 cos of x. All right, so then we're gonna find y dash. What would y dash be? It would be u1 dash sine x, we use the product rule, plus u1 sine x becomes cos x. All right, then u2 dash cos x minus u2 sine of x. So imagine this is like a random constraint that I am putting right on u1 and u2, which is that u1 dash sine x plus u2 dash cos x is equals to 0. So if this is true, which we are saying that it is true in our scenario, like, well, like, yo, like, this is true no matter what. Okay, so we take this constraint. So our thing is going to change because we have u1 sine x and we have u2, I mean u1 dash sine x, u2 dash cos x. which are both equal to 0. So we can simplify it and write it as u1 cos x plus, sorry, it would be minus u2 sine x. All right. So since we found that, we're gonna find its double derivative, and whatever the answer of that is, we're gonna substitute that in the main equation. So basically we would put that in y1 dash plus y. So whatever y we get, like, we would take it here. Let's say it is let's say it is u1 dash cos x minus u1 sine x. Okay, I'm sorry, I'm just gonna copy him. So basically, as you can see, you take that, you take this whole thing, put it there, you take this whole thing, you put it there, and then you equate it to sine x. When you equate it, you're gonna, this cancels out, this cancels out, you're left with u1 dash cos x minus u2 dash sine x is equals to tan x, right? So let's start on a new board. u1 dash cos x and plus u2 dash sine x is equals to tan x. All right, and given what we're gonna do is we're gonna remember to put this in the main equation, and from that you're gonna get what we got. Okay, now next what we're gonna do is take the constraint constraint equation and turn it into a simultaneous equation. So what was the constraint? It was u1 dash sine x plus u2 dash cos x is equals to 0. So if you multiply everything by cos, this would turn to cos square, this would be cos sine, and this would be tan into cos, and then we'd have, sorry, cos square, and then we'd have cos sine. So then what we can do in this scenario is we can eliminate I am sorry. So in the other scenario, you're gonna multiply it by sine, the whole equation. So this will turn to sine square x. This will be the sine. So basically, you subtract this, then u1 cos square x minus u1 sine square x equals to tan x cos x. Alright, so then you get u1 dash, so basically cos square minus sine square x is 1, so tan x cos x, and then u1 is the integral of that. Alright, and then you substitute it and then you find u2. Yeah, that's it.